All right. Hopefully, you guys can hear me. And we are going to go ahead and do the lesson for today since we're missing class. And let's go and start with the problem of the day. Find the derivative of these two equations. Now, our first one, what are we going to do in order to take the derivative? We have a function divided by a function, so we're going to use quotient rule. So it'll low d high minus high d low over low low. All right, so remember what we said yesterday, our derivative of e to a power is always going to be e to the power times the derivative of that power. So in this case, we take that derivative, we have low d high. So low d high, which is going to be e to the 3x times 3 minus high d low. Now the derivative of e to the 3x plus 1 is actually going to be the same as the top. It's going to be e to the 3x times 3 again, because that plus 1 goes away. And the bottom is going to be low e to the 3x plus 1 squared. Okay. Oh, that's gross. Let's see if we can do any simplifying here. All right. Well, if I were to go ahead and take out, notice that both of these have this 3e to the 3x. Let's pull that out. So if I pull that out, I get 3e to the 3x times this guy, e to the 3x plus 1 minus e to the 3x. Still all over are e to the 3x plus 1 squared. But what if we simplify what's inside here? What's going to happen? If I drop the parentheses, since I don't need parentheses in this case.
1.
Yeah, the e to the 3x's are actually going to cancel out. All right, if we go ahead and get rid of the parentheses, we don't need those. These guys cancel out, and you just get 1. So our final answer is actually just 3e to the 3x over e to the 3x plus 1 squared. Okay, so we got to make sure that we can go through all of our simplifying that we may have to do to make sure that we can find the answer to the multiple choice. As you saw in the last test, the multiple choice, finding those answers tends to be the killer. All right, you got to be able to simplify all the way down and figure out which answer is actually going to be our one that we have to select. A lot of you just chose not there on the last test. All right, or none of these. You got to be careful when choosing none of these. You got to really make sure that the answer is not there. All right, for our next one, all right, we had y equals 5 e to the x plus e to the negative 2x. Now with this one, there's a couple ways that we can do it. The easiest way, like I would not do quotient rule with this. The reason I would not do quotient rule is because up top is just a constant. So if that's just a constant, I can bring up the bottom as 5 times e to the x plus e to the negative 2x to the negative first, and then just use chain rule. It's easier that way. All right. So if I go ahead and do chain rule with this, bring down the negative 1, so negative 5. Move this up. That drops to the second power, and then d stuff. So what happens if we take the derivative of our stuff here? What's the derivative of e to the x? E to the x. And then we have e to the negative 2x. What's that actually going to be? Minus 2 e to the negative 2x. Good. And so if we wanted to rewrite that as a fraction, which we can. All right, bring this over here. I can just rewrite this as negative 5 times e to the x minus 2e to the negative 2x all over e to the x plus e to the negative 2x squared. And there's really not much I can do with that. That's simplified as much as it can be simplified. So that would be our final answer with that. Okay. All right, before I start answering questions on homework, I do want to actually get through the lesson with the time that we have. And I will take questions at the end of that. But let's go ahead and take a look at the second part of 5.4. Now, 5.4 is all e to the x. All right, 5.4 is all e to the x. Well, yesterday we learned the derivatives of e to the x. Today we're going to learn the integrals. Okay, so we're going to look at the integrals of e to the x, and you'll never guess what the integral of e to the x is. E to the x plus c. Don't forget the plus c. But yes, our integral of e to the x is just e to the x plus c. So not much different from what we did with derivatives. The only thing that I'd be careful of is obviously just like with derivatives, we use a lot of chain rule. With integrals, we're going to use a lot of u substitution. So everything we do with e to the x usually is going to have something in it. Okay, it's not, you're very rarely going to see just an integral of e to the x. So we've got to make sure that we're ready to look at things that might be a little bit more complicated. Okay, so let's do some examples today. So we have the integral of e to the 3x plus 1 dx. All right, so this is a typical e to the x integral that we deal with. We have stuff inside the exponent. So what are we going to make our u in this case? 3x plus 1. U is 3x plus 1. So we take the derivative of that. Du is going to be 3 dx. And what are we missing? What do we not have in front of it? We don't have the 3. So let's go ahead and put a 3. And out front, we're going to put a 1/3. So now from there, we got 1/3 integral of e to the u du. And the integral of e to the u du is just e to the u. So this is going to give us 1/3 e to the u plus c, and then we can go ahead and put our u back in there, which was 3x plus 1 plus c. Okay, so pretty straightforward, and you can always go back and check it real quick. If we take the derivative of this, we know the derivative is going to be e to the 3x plus 1 times the derivative of 3x plus 1, which is 3, cancels out the 1/3, gives us what we started with in the beginning. All right. Let's take a look at a couple more. A lot of times you're going to see something like that. All right, so now we got a little extra going on here. But if we look at our exponent, negative x squared, what's the derivative of negative x squared? Negative 2x. So we have an x there. So this is still just a u substitution problem. They just threw a couple extra constants in there. So let's go ahead and do u substitution again. All right. But what I'm going to start off with this problem, this 5 is kind of in the way. So du is going to be negative 2x dx. So I have the x and I have the dx, but I need a -2. Since that 5's in the way, I'm going to take that 5 out. Break apart. Break that out to the outside. All right. By doing that, now it's not really in the way. Now I can go ahead and add my -2 that I need. And what's going to go out in front with that with that 5? -1/2. And remember, we multiply with that. So in this case, we're going to get -5/2 integral. Now I have everything for e to the u du, which we know is just going to be e to the u plus c. So -5/2 e to the u is -x squared. Do this first. So -x squared plus c. All right, so kind of your standard u substitution that we've seen. Sometimes we got to take out that constant to make life a little bit easier for us, but really nothing that we haven't seen already this year. All right, so let's go ahead and take a look at 2 more examples from there. I want you guys to try these out. So 2 examples, go ahead and give those a try. What are we going to make our use for the first one? 1/x. All right, we're going to make that 1/x because if we make that x to the negative first power, our du is just -x to the negative second dx. Well, remember, x to the negative second, that's just -1/x squared. And if we see, hey, we got that right there. What are we missing though? Negative. We're negative. So put the negative there. Then we end up with just negative integral of e to the u du. And then we're just going to get negative e to the 1/x plus c. We'll put that u back in. All right. What are we going to make u for our second one?
Cosine.
Cosine. And so if we make u equal to cosine of x, du is just negative sine of x. And what are we missing?
Negative.
Negative, same thing as this one. So we go ahead and put the negative in. And we just have integral, or negative integral e to the u du. So that just gives us negative e to the, let's put u back in, cosine of x plus c. Okay, so pretty much the same idea with all these. It's just really paying attention because we can add any of our integrals that we've learned so far. So that includes natural logs. All right, they like to throw natural logs and these together because things cancel out and it actually gets a little bit nicer there. All right, so you're going to see a lot of things that you may recognize from the last section with natural log that they just threw e to the x in there somewhere. All right, let's do one more example, and then I want to jump into some homework questions with the time that we have. Well, let's do an application type question. So this test is definitely going to have more application than the other ones I've had. Get to that point where it's time to start reviewing all those things. Find the area under the curve on the given interval. We're looking at y equals e to the x over 1 plus e to the x. All right, so we want to find the area under the curve on the given interval, y equals e to the x over 1 plus e to the x from 0 to 1. Now, when we find the area under the curve, remember this is chapter 5. This isn't chapter 7. We did area under the curve, or area between two curves. We did top minus bottom. This is just the area under the curve, which is really what a definite integral finds us. It's just area between that and the x-axis. And we saw this on our recent test. All we have to do is integrate this over the given interval. So we're going to set this integral up from 0 to 1, e to the x over 1 plus e to the x dx. There's our setup for this. Now we just got to know how to recognize how to integrate this. So what am I going to do to integrate it? Okay, what's our u going to be? Not going to get us anywhere. All right, this is what I'm saying. You got to think about some of the stuff that we may have seen recently. 1 plus e to the x. Let's make that our u. Let's make u equal to 1 plus e to the x. Well, what is du going to be in this case then? It's just e to the x dx. Isn't this just u prime over u? Yeah. And if we have u prime over u, that's the integral for what?
Natural log.
Natural log. So this is actually just natural log absolute value of 1 plus e to the x evaluated from 1 to 0. And so this is what I'm talking about. A lot of times you're going to see natural log integrals where it's 1 over something where they're going to throw an e to the x in there. And so you want to recognize, okay, if I see that that derivative of the denominator is up top, it's just a u prime over u situation. Okay? If we had made the ux, it really doesn't get us anywhere. It just tells us du equals dx. We're stuck. So then you got to think about what else could u be. And since we're dealing with a fraction, one of the other things we've seen is that we can make the denominator equal to the u. But now if I go to plug in the 1, we get natural log 1 plus e to the first minus natural log of 1 plus e to the 0. Well, what's 1 plus e to the 0? What is e to the 0? 1. It's going to be 1. So this is actually natural log 1 plus e minus natural log of 1 plus 1, which is 2. How can I rewrite this to make it a little bit more simple?
Natural log of 1 plus e over 2.
You've got it. We can use that quotient property we learned 1 plus e over 2. And we really don't need the absolute values because that's already positive. So we're actually good with that. So they like to throw that e to the x into a lot of different things. I actually did have one more example for you of a definite interval. So this is another case where they're using something we've already done, but they just threw e to the x in there a couple times. So you gotta think about what's your u gonna be with this. Too much.
Just cosine.
Not cosine.
Just e to the x.
We're gonna use the e to the x that's inside cosine, right? So if we did u equals e to the x, du is e to the x dx. Hey, there it is. And so now what we can do is actually just do the integral of cosine of u du. What's the antiderivative of cosine? Sine. This is going to be just sine of u. Let's put u back in, e to the x. And that's from 0 to -1. So we're going to put that in. Sine of e to the 0 minus sine of e to the -1st. Well, we can't do much with sine of e to the -1st. That's not on the unit circle. But we can do something with e to the 0. What's e to the 0? That's just 1. Well, actually, no, I lied. We can't do anything with that either. We're out of luck. No, that's it. Can't do anything with that. Perfect. Yeah. So really, can't do much with. Yep. All right, so even plugging that in, we have values that aren't on the unit circle. We'll see that more and more with trig when they throw trig into these type of problems. All right, but that's really the end of 5.4 with the integration. So give a bunch of examples of u substitution problems, but it's all really just the same idea, this whole idea of u to the x. Okay. So what we'll do tomorrow is actually answer questions from both tonight's homework and yesterday's. Please bring ones from yesterday because there's some really good questions from last night's homework, like 87 was really good. That's a great one.